Hey guys, hey today I'm going to talk to you about radical inequalities or solving radical inequality type of problems. And so let's check that out here. Here I have an example. I have an example of 3 times the square root of 2x minus 1 plus 6 is less than 15. So this is called a radical inequality. The inequality because I have an equality sign. And the radical, I have this square root. The square root, or any root type of sign, is called a radical sign. So the one thing I'm going to be interested in is my allowable answers, which we call the domain. And so the way I find a domain for a square root is I set what's underneath the square root greater than or equal to 0. So if I set 2x minus 1 greater than or equal to 0, by adding 1 and dividing by 2, if I add 1 and divide by 2, because I'd have 2x is greater than 1, I get x is greater than or equal to 1/2. So this is my domain. Now that means that I can only use the values that are greater than or equal to 1/2. So I want to see what my answers are and then compare them with that. Okay. So what I want to try to do when I solve these radical inequalities or even regular equations, radical ones, is I want to isolate my radical sign. So I want to, in this problem, I want to get rid of this plus 6, excuse me, plus 6, and this 3 being multiplying by 3 here. So I get rid of that 6 by subtracting 6 from both sides. So if I take 6 away from 15, I'd be left with 9 over there. And if I get rid of this 3 by dividing, so if I divide that by 3 and divide this by 3, I end up with this inequality. 2x minus 1 is less than 3. So now this is my inequality, my radical inequality that I have isolated. Now the way you get rid of a square root is by squaring. So if I square both sides of this, I end up with 2x minus 1 is less than 3 squared, which is 9. Now from here, it's a pretty simple equation here, or inequality. I would add 1 to both sides, giving me 10 over there, and just 2x over here. So I'd have 2x is less than 10, and now to divide both sides by 2, I would have x is less than 5. Now, my answer is not just x is less than 5, because there's lots of values less than 5 that I need to think about with my domain. Now, my domain says that I have to use values of x that's greater than or equal to 1/2. So I kind of have a little combination of an answer here. I have to think about the things that are less than 5, but I'm not allowed to use like numbers like negative 100, because negative 100 is not greater than 1/2. And so my solution looks like an interval, and it looks like this. X would be between 5 and 1/2. So my answer would be 1/2 is less than or equal to x, which is less than 5. So that's called an interval. Now there's another way to write an interval called interval notation. And just for kicks, I'm going to show you what that would look like. Interval notation would have a bracket with 1/2 and then a comma, and the 5 would have a parentheses. Now the reason for the bracket is because in this interval this first x is greater than or equal to 1/2. The equal sign implies that we're going to include that, and so we use a bracket for that. If you look back here, this does not have an equal sign, so we use a parentheses for things that are when they're not equal to. Okay. So our answer here for this example is 1/2 is less than or equal to x, which is less than 5. Now, I would like to talk about another type of question, which doesn't involve a square root, but a cube root. So I'm going to put that up here now. I'm going to say I have the cube root of x minus 2, and I'm going to say it's going to be greater than or equal to 7. Okay? Now here's the thing. With cube roots and any odd root, you don't have to worry about the domain so much. Like the domain was kind of restrictive with the square roots or even roots. The cube roots or odd roots are a lot nicer to work with because you can have negatives underneath a cube root. And so I actually can use all numbers, all real numbers would be my domain for this particular one. So I don't have to worry about that domain stuff as much. I can just attack this problem like I would do any other problem by just cubing both sides, because to do the inverse operation of cube rooting would be cubing. So I'm going to raise both sides to the third power, and this would leave me with this expression. 7 to the 3 is 7 times 7 times 7, which would actually give us 343. Now, pretty simple to solve this. I'm just going to add 2 to both sides. And I'd have x is greater than 345. Greater than or equal to, sorry. So solving a cube root is a lot nicer than solving a square root because you don't have to worry about the domain so much, because the domain can be all real numbers in a cube root or any odd root, such as a 5th root or a 7th root. So I hope this helped you solve your inequality questions, and look for me to post some more videos in the future.